Jai Hind to everyone. My name is Mili Srivastava, Assistant Professor in AKGEC Margarg Engineering College from IT Department. And today I am going to discuss about structure of operating system. So what is operating system structure? These are some components of operating system structure and how we define operating system structure into different types. That is system component, operating system services, system calls, system program, system structure, virtual machines, system design and implementation, and system generation. These are some basic structure of operating system. Now, what is system component? In system component, there are some keywords like process management, main memory management. In system component, we decide how to manage, how to cover difficulties in system component. So, how to describe main memory management, how any process management, like which process it enters into main memory according to secondary memory. Now, next is file management. System component, basically system component manages process management, main memory management, file management, input output system management, secondary memory management, networking, protection system, command and interpreter system. So these are the components of system components. Now, what is process management? So, a process is in a, what is process? A running program is called as a process. Whenever a process is in running state, that is called as a process. So, a process is a program in execution. A process needs certain resources including CPU time, memory, file and input-output devices to accomplish its task. So, a process is program in execution. Whatever we need to describe, the operating system is responsible for the following. There are some activities which are handled by operating system, that is process creation and deletion, process suspension and reassumptions, and provision of mechanism for process synchronization and process communication. Next is, what is main memory management? Main memory management, as we know that main memory directly attached with the CPU. So, only running process and the process that goes to run are inbuilt in main process, main memory. So, main memory is a large array of words or bytes, each with its own address. It is a repository of quickly accessible data shared by the CPU and the input-output devices. Now, main memory is a volatile storage devices, as we all know that main memory is a volatile storage devices. So, we use that's why we use secondary memory, and it losses its contents in the case of the system failure. So, whenever we talk about operating system is responsible for such activities in connections with memory management, that is keep track of which part of memory are currently being used and by whom. Now, allocate and deallocate memory spaces are as needed and decide which process to load when memory space becomes available. So, these are the main responsibilities of main memory management system. Now, next is file management. In file management, what is file? Basically, what is a file? File is a collection of related and informative data. Now we can say that a file is a collection of related information defined by its creator. Now, commonly file represents program both source and object forms and data. And in the operating system, it is also responsible for such activities in connections with the file management, that is file creation and deletion, modification, updation, directory creation, deletion, support of primitive of manipulating files and directories, and mapping files onto secondary storage, and finally file backup on stable non-volatile storage media. That is, these are some responsibilities of file management. Now, what is input-output management system? Input-output management system consists basically buffer caching system and a general device driver interface and drivers for specific hardware devices. And in that case, in the case of secondary storage management, why we use secondary storage management? Since main memory, primary storage, can also said that main memory as a primary storage is a volatile and too small to accommodate all data and programs permanently because it's volatile memory. So the computer system must provide secondary storage to back up main memory. Now most modern computer systems use disk as the principal online storage medium, and for both programs and data. And in case of operating system that is responsible, what is secondary storage management? Responsible for such activities in common with disk management, that is free space management, storage allocation and disk scheduling. Now next is networking, or we can say that distributed system. What is distributed system? A distributed system is a collection of processors that do not share memory or a clock. Each processor has its own local memory. Now the process in the system connected through a communication network. So we can say that communication take place using a protocol, such protocols like TCP, IP, HTTP, and the distributed system provides user access to various systems resources and access to shared resources, and this in this case access to shared allocation allows computation speed up, increased data availability, enhanced reliability. These are the some key points of networking in operating system. Now next is protection system. What is protection system? Protection refers to a mechanism for controlling accesses by programs, processes or users to both system and user resources. Now the protection mechanism must have distinguish between authorized and unauthorized uses, specify the control to be imposed and provides a means of enforcement. These are some points. Next is command interpreter system. What is command interpreter system? Many commands are given to the operating system by control statement which deal with the process creation and management, input output handling, secondary storage management, main memory management, file system access, protection and networking. These are some mechanisms of command interpreter system in operating system. Next, now a command interpreter is a part of computer operating system that understands and executes commands that are entered interactively by a human being from a program. Now, the program that reads and interprets control statement is called variously like command line interpreter and shell. What is shell and command line interpreter? I already discussed in my first lecture. Its function is to get and execute the next command statement. So, basically in the structure of operating system there is also some services like program execution, input output operations, files system manipulation, communication and error detection. So what is program execution? In program execution, first of all I already told you ki, what is process. A running program is called as a process. So in program execution, system capability to load a program into memory and to run it. This is program execution. Next is input output operation. What is input output operation? Since user programs cannot execute into input output operations directly, the operating system must be provide some means to perform input output. Now what is file system manipulation? In file system manipulation, program capability to read, write, create, update and delete files. This is file system manipulation. This is called as known as file system manipulation. Next is communication. What is communications? Exchange of information between processes executing either on the same computer or different systems tied together by a network, that computer, and implemented by a shared memory or messages passing through via that computers. Now, next is error detection. What is error detection? In error detection ensures correct computing by detecting errors in the CPU and memory hardware, in input-output devices, or in user programs, that is operating system services. Now, there are some additional operating system functions, that is resource allocation, accounting, and protection. So, what is this? In additional functions exist not for helping the user, but rather for ensuring efficient system operations. That is resource allocation. In resource allocation, that is allocating resources to multiple users, to multiple jobs running at the same time. Next is, what is accounting? Keep track of and record which users use how much and what kinds of computer resources for account billing or for accumulating users status. Next is protection. That is one of the most important part of any file system or structure, that is ensuring that all accesses to system resources is controlled. Now, next is system calls. What is system call? System call is one of the most important part of operating system. With the help of system call, operating system calls with the help of kernels and shells, operating system calls that data which needed by user. So, system call provides the interface between a running program and the operating system with the help of kernel and shells. So, generally available as assembly language instructions, that is languages defined to replace assembly language for system programming, allows system calls to be made directly. That language may be C, C++, Java, or any other language. Next, three general methods are used to pass parameters between a running program and the operating system, that is pass parameter in registers. Next is store the parameters in a table in memory, and the table address is passed as the parameter in a register. What is push operation? Push is the parameter onto the stack by the program and pop off the stack of the operating system. So, that is push and pop operation, which we already discussed in data structure. Next, there are some types of system calls, that is process control, file management, device management, information maintenance, and communication. What is system programs? This is system calls. And what is system programs? System programs provide a convenient environment for program development and execution that can be divided into some common points like file manipulation, status information, file modification, programming language support, program loading and execution, communication, and application programs. Most users' view of the operating system is defined by system programs, not the actual system calls. Now, MS-DOS system structure. This is example of system structure, operating system structure. This is MS-DOS system structure, and this MS-DOS system structure written to provide the most functionality in the least space, not divided into modules. And although MS-DOS has some structure, its interfaces and levels of functionality are not well separated, as MS-DOS written to provide the most functionality in the least spaces. So, this is example of structure of operating system, and this is structure, how it works. This is application program, resident system programs, MS-DOS, device drivers, and ROM BIOS. device drivers. This is a structure of MS-DOS layer structure. Now, second example, this is Unix system structure. What is Unix system structure? As we all know, Unix is basic unit of operating system limited by hardware functionality. The original Unix operating system had limited structure. So, the Unix operating system consists of two separable parts, that is system programs and the kernel. In Unix, there is is two parts, that is system programming and kernel. So, what is here? Consists of everything below the system call interface and above the physical hardware. And next is provides the file system, CPU scheduling, memory management and other operating system functions. A large number of functions or for one level, that is physical hardware. This is structure of Unix operating system. Next is layered approach. What is layered approach? Layered approach is approached basically as named here, layered approach. So, there are some layers operating system. The operating system is divided into a number of layers, or we can also say that layers or levels. So, each built on top of lower layers. Now, in this case, the bottom layer known as layer 0 and is the hardware, the highest layer, and is the user interface, depends on how many layers are there in that structure. Now, with modularities, layers are selected such that each uses functions, operations and services of only lower level layers. This is diagram or example of layered structure. We can say that layer M and layer M-1. This is next layer of layer M-1, and this is next layer of M-1 layer. So, it is known as M. This is also one example of layered structure. We can say that there is application, these are the application and application. This is this layer used as an interface between application and the subsystems of these systems. This is subsystems, this is kernel, and these are the drivers. Next is microkernel system. Microkernel system structure. What is microkernel? As we know that moves such from the kernel into user space, communication take place between user modules using message passing. So, there are some benefits of microkernels. What is easier to extend a microkernel, easier to port the operating system to new architectures and more reliable. Less code is running in kernel modes and more secure also. This is more secure also. So, this is microkernel structure. Next, Windows NT client server structure. What is NT client server structure? This is same as client server structure. When we talked about client server structure, what is there is some kernel server, and these are the clients servers in which applications run on this server. Next is virtual machine. What is virtual machines? Virtual machine takes a layered approach to its logical conclusion. It treats hardware and the operating system kernel as though they were all hardware. The virtual machine provides an interface identical to the underlying bare hardware. In this, the operating system creates the illusion of multiple processes, each executing on its own processors with its own virtual memory. This is virtual memory. And there are some resources of physical computer are shared to create the virtual machine. CPU scheduling can create the appearance that users have their own processor, and the spooling and the file system can provide virtual card readers and virtual line printers. And in some cases, a normal user time sharing terminal servers as the virtual machines operators console. Now, this is the system model of virtual machine, how it implements and works. This is hardware, kernel, process. These are some virtual machines implementation, and virtual machine 1, virtual machine 2, virtual machine 3. This is simple basic structure of virtual machines model. And now I am going to discuss about advantages and disadvantages of virtual machine, which is also very important for implementing any virtual machine. We know that very well. Now, what is advantages and disadvantages of virtual machine? The virtual machine concepts provides complete protection of system resources, since each virtual machine is isolated from all other virtual machines. So, this isolation, however, permits no direct sharing of resources. A virtual machine system is a perfect vehicle for system research and developments. In system development is done on the virtual machine instead of an physical machine, and so does not disrupt normal system operation. And thus the virtual machine concept is difficult to implement due to the effort required to provide an exact duplicate to the underlying machine. This is one example of virtual machine that is which is created in Java. How it works is JVM. This is called as JVM, Java Virtual Machine. JVM consists of class loader, class verifier, runtime interpreter, just in time. What is just in time? JIT. Compilers increase performances. And I am going to show this is Java virtual machine structure, JVM structure, java.class file, class loader, verifier, Java interpreter, and this will interact with the host system, whatever with it. Now, next is system design goals. What are the system design goals? User goals. Operating system should be convenient to use, easy to learn, reliable, safe and fast. And system goals, operating system should be easy to design, implement and maintain, as well as flexible, reliable. It is flexible, reliable, error free and efficient. This is system design goals. Now, mechanism and policies. Mechanisms determine how to do something, policies decide what will be done, and the separation of policy from mechanism is very important principle. It allows maximum flexibility if policy design are to be changed later. Now, what is system implementation? Traditionally written in assembly language, operating system cannot be written in high level languages. Code written in a high level language written faster, is more compact, or we can say that it is easier to understand and debug. An operating system basically is far easier to move to some other hardware if it written in a high level language. This is system implementation. And last is system generation. What is system generation? Operating system are designed to run on any of the class of machines. The system must be configured for each specific computer sites. And what is next system generation program obtain information concerning the specific configuration of the hardware system. And what is booting system? Booting basically what are the work of operating system, that is known as booting. Booting is starting a computer by loading the kernel, and it is used by and it is operated by kernel system. Now, as we discussed, I discussed already, operating system is further divided into two parts, that is kernel and shell. So, booting, when we boot a system, we start a system, then starting a computer by loading the kernel part of operating system. Next is bootstrap program. code is stored in ROM that is able to locate the kernel, load it into memory and start its execution. That is bootstrap program, which is also very important part of operating system. So this is all for today. Thank you so much.